proof is now on the math specification in much more depth than it used to be, and I think it's a great thing because it's actually at the heart of maths. I'm not going to go into any more detail on that, but you might want to investigate the concept of proof. There's lots of different types, and it goes into in even more detail at A level, and you can prove some absolutely amazing results. Right here, I wouldn't say this is an amazing result, but it's it's decent. Prove that the mean of any 4 consecutive even integers is an integer. Okay, we need to think about what this means to start with. And I think a little example can be useful. It's not a proof, but it just gives a feel for what's going on. So let's start with 2. So 2 can be my first even integer. And for them to be consecutive, I'm then looking at the one after it. So 4, and then 6, and then 8. And if I add them up and divide by how many there are, 4 in this case, then I'm trying to show that I will necessarily get another integer. So I can do 2 plus 4. You might say I should be doing this in my head, but I'm doing it with the calculator. Divide by 4, I'm going to get 5. So it works for this one. That's not a proof, that's just me getting a feel for it. Okay, I want to show that it's always true. So for the proof, I'm going to let x be the first even integer. Actually, herein lies a problem, because how do I guarantee that x is even? And I need to do a little bit more, actually. I need to say that x is going to be, for it to be even, it has to be twice another integer. X equals 2 times n. N is also an integer. And actually, I've realized I didn't even need to introduce x. I could have just said 2n. So I'm going to replace x. I don't mind that I did it, but let 2n be the first even integer, where n is an integer. And then the mean of 2n plus the next one, which is 2n plus 2, plus the next one, which is going to be 2n plus 4, plus the next one, which is going to be 2n plus 6. That's going to be my 4 consecutive integers written generally, and then I'm going to divide that by 4. We're working algebraically, but in a similar way to before. I'm going to combine the n's, that will give me 8n. I'm going to add the numbers, that will give me 12. And now I just need to simplify this. You can simplify this in 2 ways. The first way, I'm actually going to factorize out a 4 from the 8n. That's in fact it is the highest common factor that goes into 8n and 12. And then I'm going to divide it by 4. And what I can then do is cancel these out. So I'm left with 2n plus 3, which is also an integer. The second way I could have done it is I could have actually directly divided this term by 4 to give me 2, but also this one by 4 to give me 3. Sometimes you can see that as quick division. 2n plus 3 is okay to do it because there's a plus there, but we do have to divide both by 4. In any case, we get 2n plus 3. We just need to say it's an integer, and my proof is complete. I might just add that at the end. So I'd say my main points here are, feel free to try, if you're not sure where to start with a question like this, try some numbers, just see that it works, and then try and link it to how do you prove it. You need to work generally. And I did actually start with x, but in this case, because it's an even integer question, I need to change that and make it a multiple of 2. 2n is your classic even integer. 2n plus 1 is your odd integer. You get that, you just then need to use the fact they're consecutive, but I can see from my example I'm just adding 2 every time, so hopefully see where that comes from. I divide by 4 because there's 4 of them, I bring it together, and even if you didn't quite get to that bit, you're most of the way there, but hopefully you're happy with it now. Well done.